Hello everyone, thank you for joining. Today we're going to talk about Code Your Cloud, Infrastructure as Code, Best Practices with Terraform. My name is Madhu Kumar Yeluri. In this presentation, we will discuss how Terraform as an infrastructure as a code tool helps manage your cloud infrastructure effectively. We'll also cover some best practices for creating scalable, secure, and maintainable cloud infrastructure. A little bit more about me. I'm a principal cloud architect and DevSecOps consultant, helping many customers to migrate to cloud and also help them with DevOps processes, helping with the infrastructure as a code on infrastructure designs, end-to-end automations, security, etc. I'm also an AWS hero and lead many global dev communities like AWS User Group, HashiCorp, DevSecOn, which is Sneak, and DevOps Institute, which is PeopleCert, as a chapter leader and brand ambassador. If you want to learn more about me, please scan the QR code and connect me on LinkedIn. Infrastructure as a code or IAC is a powerful way to manage cloud resources by writing the code rather than manually configuring each resource, like going through the console, click, 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 create your resources, which is really hard to manage your cloud infrastructure. But IAC provides consistency, allowing you to version control your changes, makes it much easier to scale infrastructure. Today, we will focus on how using infrastructure as a code, specifically with HashiCorp Terraform, can enhance your cloud deployment. So let's begin by defining IAC. Infrastructure as code means describing your cloud infrastructure using code. This approach enables consistency in your configurations, allowing us to track changes and makes deployments more repeatable. So, by coding infrastructure, you can avoid manual errors, reducing manual configuration, and deploy much faster. So, why Terraform, right? So, first, HashiCorp Terraform is provider agnostic, meaning it can work across multiple cloud platforms like different hyperscalers like AWS, Azure, and GCP. It uses a declarative language called HCL, HashiCorp Configuration Language, where you define the design end state rather than the exact steps. So Terraform also has a strong community and ecosystem with reusable modules, making it ideal for infrastructure as a code. In this session, we will cover best practices for Terraform, including organizing code, using modules, how we manage the state files, handling environments, implementing security measures, and testing the automated deployments. These practices are essential for creating efficient, scalable, and secure infrastructure in your cloud. Organizing code structure. So, to keep Terraform code more organized, it's very important to structure it by service or component, such as like you can see in the picture on the right hand side, segregate by network, like database or your application layers. Use a consistent file naming convention like main.tf. TF is an extension for Terraform. For main configurations, variable.tf for input variables, outputs.tf for outputs. A clean structure makes it more easier for your teams to find and manage specific configurations. Modules for reusability. So modules are the key when you're writing a reusable code in Terraform. By using modules, you can create reusable standalone pieces of code, which are like common infrastructure patterns, such as VPC. It's a part of your landing zone in any cloud infrastructure. It's a best to design modules with clear inputs and outputs and to keep them focused on a single purpose for better maintainability. State management. So Terraform state file tracks your current state of your infrastructure, and which is very important and a key file in Terraform. To avoid conflicts and enable team collaboration, store the state files remotely, such as in a S3 bucket. Use DynamoDB for state locking. Securing and versioning your state files is very critical to prevent any sensitive data leaks and also to avoid any state file corruptions and yeah, make it more secure. When it comes to environment segregation, for example, if you're working with multiple environments like dev, staging, and production, it's very important to isolate each environment using Terraform workspaces or directories. I think it's not part of a community edition. Maybe it's a paid version. There are some paid versions, features that you get. But this is very critical for basically multiple developers working in different environments. This isolation also ensures that changes in one environment won't impact the others, and it makes it your deployments more predictable and manageable. Security is a ground zero in a cloud, and it's very crucial in infrastructure as a cloud. So avoid hard coding secrets and instead use secret management tools like AWS Secrets Manager or HashiCorp Vault. So grant least privilege access. That's the least privilege principle that you do to adopt in any cloud environment, and it's very necessary, very required to developers, and enable auditing to track changes, what the changes you're implementing by doing a version control of your Terraform files. So in a version control tool like Git or Bitbucket and any tools, version control tools you use. So this approach not only safeguards your sensitive data but also keeps your infrastructure more secure. So automation and test introducing in your infrastructure is also very essential. So automation is essential for consistent infrastructure deployments uh, by integrating Terraform with CI/CD pipelines like GitLab pipelines or code pipeline on any AWS, whatever your pipeline Jenkins or in pipelines you use. So you can automate testing, validation, and deployment of your infrastructure end to end without any manual intervention. Uh, Use tools like TerraTest or Checkout for testing to ensure your configurations are secure and correct. So anything goes wrong, basically you stop the pipeline, you try to fix it, send an alert to your development team, and you restart your pipeline again. So that helps you a lot before it goes to your actual test environment or your final production environment. This automated pipeline will help you smoothen out and avoid any early errors and detect them at the early state. Managing the drift and consistency. So infrastructure drift occurs when you manually change the things outside Terraform. So some developers tend to go to the console and make a change to fix something, for example, so to debug something. So it's always the best practice to avoid manual changes directly and do that via your infrastructure as a code like Terraform and maintain that consistency. So regularly run Terraform plan to detect these changes, any conflicts, and consider adding automated drift checks as part of your DevOps pipeline. Detecting drift in the early stages, like I explained in the previous slide, it keeps your infrastructure consistent and avoid any surprises. So let's look at this example workflow, right? So deploying an Amazon VPC with multiple subnets. So any application if you want to run or any resource you create in a cloud infrastructure, the first basic thing you do is to establish your landing zone, which is creating a VPC, subnet, security before you even host or create any of your application components in the cloud. So by following these best practices like reusing the modules for the VPC, storing a state file remotely in S2 bucket, and like we discussed, and using the CI/CD automation, put your secrets in your secret manager bit or HashiCorp Vault. So this follow these best practices which we discussed in the previous slides. You can create a scalable, maintainable, and a very consistent cloud environment. So challenges and solutions are the most challenges I face personally when I support my customers when I implement ISC, infrastructure as a code, are such as like state conflicts. Mainly, somebody changes randomly console, and when I do a Terraform plan, I got a conflict, so I did basically have to see what happened and resolve those conflicts. So, and then I had a chat with the development team, say avoid manual changes and try to be, more consistent to do the changes as part of Terraform code and not manual changes. So the another thing is the sensitive data management. So I've seen some of the developers have, I mean, just a quick fix. They put the secrets in part of the code, which is not a good practice. So I advise them to put it in the a secrets manager or a world outside the code, a more secure way to obtain it during the runtime when you're creating the infrastructure, rather than hard coding it somewhere. So that's another common thing I've noticed. So to avoid this, like we discussed in the previous slide, so solutions include using Terraform workspaces for environment isolation, uh, for security, managing state files securely, and integrating your CI/CD for automated testing. So this, by addressing these challenges, you can deploy infrastructure more reliably. So additional tools and resources, I mean, there are too many of open source tools and too many, enterprise tools which will basically improve your workflow, how you deploy in your cloud environment. But I personally used and recommend to use like Terraform Cloud Enterprise version, provides you additional features, uh, and also features like policy management, Torah you can simplifies workflow for larger teams. Finally, explore community resources such as Terraform registry and GitHub repositories for ready-made modules and examples. But don't blindly copy them and just deploy it, because yeah, you also have to make sure there's no sensitive information that you would involve, or the code is appropriate for you guys to use it directly, or modify it to customize it to make sure it fits your purpose. So, key takeaways, just to summarize, remember the best practices for Terraform. Uh, Structure the code consistently, use modules, prioritize security. I can't stress enough. Prioritize security, ground zero, security. So, like passwords, your state file, your least privilege principles. You please implement all of that. Consider when you design an architecture. Automate with CI/CD pipelines to smoothen up your development lifecycle. So, follow these practices will help you create scalable, secure, and maintainable infrastructure with Terraform. So, with that, I think thank you for listening. I thank Garima and all the other community members as part of this event. So, thanks Garima and team for giving me an opportunity to talk. And yeah, there are a lot of talks throughout the day. So enjoy the other talks, and yeah, let me know if you want to learn more about any of the components that we discussed today, Terraform or infrastructure as a code. Just connect me on LinkedIn, and yeah, we can take it from there. Thank you guys. Have a good day, and see you soon. Bye bye.